Hello, ladies and gents. Hopefully, you're having an amazing day. Today, I got for you some supernovas. Why? Because why not? You know, in a nutshell, posted Kurzgesagt. Please, somebody tell me how to pronounce it if I'm saying that wrong. I feel like I'm butchering that, and I just call them in a nutshell. Cause it's like, yeah, I'm not getting that one right. But we got supernovas. We recently watched a video on supernovas. But fuck it, let's watch another one, man. Let's go. Let's just do it.
Supernovae are the most powerful explosions in the universe, unleashing enough energy to outshine galaxies. We have no real metaphor for their power. If the sun were to magically go supernova, it would feel like you were being hit by the energy of a nuclear explosion every second for weeks. While supernovae are the engines of creation, forging the elements that enable life, they also burn sterile whole regions of galaxies. So what would happen if one hit Earth?
Seems everybody's interested in answering that question, huh? I guess the Veritasium video became more about just like a cool, fun way of learning about supernovas rather than really specifically going into the depths of what happens if it hits us. Let's see what in a nutshell can do. Let's see if this one is more of like what it would do to us in more detail, or if it's just like a, you know, using this fun what if scenario to get people to be intrigued about learning about supernovas. Which, I mean, supernovas are cool. You know, let's be real here.
There are, roughly speaking, two ways to make a supernova. Either the core of a massive star implodes, or, less common, a white dwarf gains mass to the point where it ignites explosive nuclear fusion. The outcome is the same, a supernova explosion. When we think of an explosion on Earth, we think of something that happens fast and ends. But a supernova is more like a volcanic eruption followed by a tsunami. At first, there's a colourful ball of hot, expanding gas, creating a spectacular cloud that will shine for about a month. But then, it doesn't stop. Hot and dangerous gas rushes outwards at speeds of 10,000 kilometers a second through the near vacuum of space, sweeping up the sparse gas of the galaxy. This wall of gas expands for tens of thousands of years and will eventually span up to dozens of light years until it finally cools off and disperses its substance back into the galaxy. So what if this star tsunami hits us? Well, the damage depends on how far away it is. Stage 1, thousands of light years away.
Okay, here we go.
Humans have witnessed dozens of supernovae, but all of them were thousands of light years away. They appeared as new stars, some outshining the moon, twinkling for a few weeks, and disappearing. Aside from looking very pretty at this distance, they don't do much to us. Stage 2, 300 light years away.
300 light years?
Things begin to get a bit icky once a supernova occurs around 300 light years away.
Okay,
we can expect one this close to us every few million years. A single star giving the night sky an eerie glow like twilight. And while this is far enough away and dim enough to not do harm to us, they can affect the Earth. At these distances, it's like being hit by the last weak waves of the star tsunami. Not strong enough to do real damage, but still noticeable. In fact, we know that over the past 10 million years, multiple supernovae have struck Earth from these distances because we can find radioactive isotopes of iron deep in the rocks and sediments at the bottom of the ocean. Amazingly, these supernovae around the solar system have cleared a 1,000 light-year wide pocket of space that's called the local bubble. They blew away the interstellar gas and dust, creating a lumpy wall of gas that's now a cradle for star formation. Stage 3, 150 light-years away. Once a supernova happens much closer than 300 light-years, we're approaching the zone where it does real damage. Stars have extremely powerful magnetic fields. When they die, the tsunami of dead star actually retains a lot of this magnetic energy woven through the shockwave that expands outwards. In this highly magnetized cloud, we get conditions like in a huge particle accelerator that's accelerating charged particles like protons, nuclei, and electrons to immense speeds. Which means we have an expanding cloud that is shooting deadly radiation in all directions long after the bright light from the initial explosion.
Okay, yeah, I said this in the other video. You know, I'm getting a whole lot of cancer that I'm seeing from this, a lot of radioactive and, you know, hazardous and just particles that you're not really wanting shooting into your body.
Away. If a supernova happens too close by, waves of these cosmic rays will wash over the solar system for thousands of years.
Ooh.
While we're mostly protected on Earth's surface by the
Some of
atmosphere,
it does go through. It's like the particles, doesn't the atmosphere kind of break them up, and then what it causes is like rainfall. So it just breaks up the ray, and it just like starts raining down bits of like the particles, like not bits of the particles, because I don't think you can have bits of particles, but it rains down the particles and stuff. Like the ozone kind of breaks it up for that which does not get completely like absorbed by it, I think, and whatever does get through, it kind of comes down in like a rainfall pattern, right? Like it just technically it rains down like radioactive particles, that which does get through, I think. Let me know if I'm wrong though, because like that was a very basic explanation that I just gave.
Sphere and ozone layer, the influx of extra radiation will still increase cancer and mutation rates. Not enough to cause a mass extinction, but it will be noticeable. Spaceflight would become impossible in the solar system, as astronauts wouldn't survive the waves of radiation for long. We don't know exactly how bad this would be, but a supernova that is close enough may trap our species on Earth for generations, maybe thousands of years. It only gets worse from here. Stage 4, closer than 100 light years.
Ooh.
Within 100 light years, things get bad, as a supernova disrupts our climate in ways that we don't fully understand yet. There are a few unpleasant things happening all one after another. First, the high-energy photons arrive from the explosion, followed by many decades of radiation from the radioactive tsunami, both of which seriously damage the ozone layer, Earth's shield against harmful radiation.
What does that
The
look
ozone
like?
layer absorbs ultraviolet radiation by breaking apart ozone, O3, into O2 and a free oxygen atom, which later reforms back into another ozone molecule. But the supernova radiation breaks up nitrogen molecules that gobble up the free oxygen, breaking the cycle and depleting the ozone layer quickly. Without a radiation shield, everybody living on the surface is exposed to very high levels of UV radiation from our sun. Cancer rates would skyrocket, and just going outside during the day could be life-threatening. The extra radiation would also kill a lot, if not most, of the plankton in the oceans that live near the surface and are the basis for the marine food chains, leading to a mass extinction.
Jeez.
Worse still, supernova radiation would ionize gas in the atmosphere, which means that it would punch through molecules and knock electrons off nuclei, leaving them charged. These charged nuclei then act as seeds for water vapor to gather and form massive global clouds.
Oh no!
In the worst case, they would reflect enough sunlight to trigger an ice age. In fact, it's thought that the ice age 2.5 million years ago was caused by a supernova. Some scientists even think that a supernova about 60 light years away might have been the cause of the Devonian mass extinction 350 million years ago. But wait, there's more. The electrons punched free by the radiation form enormous electric avalanches, or in other words, lightning. Earth is hit by some of the worst thunderstorms in millions of years. The intense lightning causes global wildfires that consume forests and crops, devastate cities, disrupt our electrical grids and global supply chains.
What?
All while a decimated ozone layer leaks deadly radiation. While in the past the ecosystem may have bounced back from a nearby supernova after a few thousand or million years, there's no guarantee modern civilization can take a hit of this magnitude. We would face food shortages, skyrocketing prices and wars as nations struggle to not be consumed by chaos. So a supernova this close would at the very least do significant damage for hundreds or thousands of years, if not end our modern civilization, and with it millions or even billions of lives. Still, humanity would likely survive and could recover. Stage 5, closer.
Let's go humanity. Reminds me of Metro. You guys ever read the Metro series? How people have to survive deep underground and like tunnels and shit. It's kind of in Russia, like that. The story takes place in like Russian tunnels, but I feel like a lot of life would be that way. Like we'd all go into the city of Ember. Like we'd all go underground to be safe from all this radioactive radiation. We'd live in like, you know, underground facilities, places, whatever, bunkers, just for metro stations, like where the Metro series comes from.
Than 25 light years. A supernova closer than 25 light years means that we're in its kill radius, where a mass extinction is all but guaranteed. Probably about half of the ozone layer would be destroyed.
And how many and I bet you, dude, they give us that existential, like, dread, bro. Give us some existential. What do you call it? Crisis. Give us an existential crisis by telling us just how many stars there are in a 25 light year radius around the Earth. Cause I think there's a good amount, right? And basically, you're telling me if any one of those were to blow up, we're all guaranteed to be dead. That is kind of frightening, isn't it?
Massive climatic disruption on a scale we've never witnessed would ravage Earth. Entire ecosystems would swiftly be wiped out by radiation as global wildfires envelop the planet. All the things described before happen, but way more intensely and much faster. A few people might survive for years in bunkers if they have food supplies, but the world they return to will be devastated and hostile to life for hundreds of thousands of years. Human extinction is extremely likely. The final stage, 4 light years.
What?
Being any closer to a supernova is very unlikely because space is big, but the effects would be extreme. Even from 4 light years away, the distance to Alpha Centauri, a supernova would be almost as bright as the sun in the sky. While casting 2 shadows could be fun for a few hours, within days the Earth's surface gets as hot as a sauna, baking the surface for weeks until the explosion fades. The surface of Earth burns, scoured of life. Even the oceans aren't safe. The massive amount of radiation that follows burns away the ozone layer, killing everything that sees sunlight.
What about
It would be
those
the largest
at the
extinction
deepest
event in history,
depths of
reducing
the
life
water?
to a few survivors in the deep sea and critters in the deep soil.
Alright, so those motherfuckers, they can still live in the deep sea? You lucky motherfuckers.
Life basically has to start over. Conclusion. How worried do you need to be? So, should you worry? No. Fortunately, there are only a handful of stars that may explode within 1,000 light years of Earth, and none are close enough to be a serious threat. Even better,
Yeah!
these stars will probably not go supernova for many millions of years.
I thought it was gonna go bad.
So you are safe. But there's no guarantee
Usually they don't even tell you that. Usually in a nutshell is not nice enough to tell you you are safe.
for the far future. As stars orbit the galaxy, our descendants may find themselves dangerously close to a supernova. But by then, a far more advanced and wiser humanity will hopefully be able to just move out of the way. In any case, you can sleep well tonight, under the beautiful night sky.
Let's go!
And if you dream about understanding the physics behind this video and others, we've created a series of lessons to build your understanding of fundamental science. Made in collaboration with our friends at Brilliant, these lessons dive deeper into topics from our most popular videos.
Sheesh. Shouts out Brilliant. The amount of times humanity could have not existed because of how the galaxy works generally blows my mind, and the fact that it also does exist only because of how galaxy works also blows your mind. So it's like weird. It's perfect. 20 million is gradually coming. You deserve this, guys. The fact that a few hundred light year away is enough to make the night glow is a real show of their power. Offers. Anyway,
Finished. This one does go in more into more depth of what would happen at different like stages of like. I like it because you know it gives you different stages of length, like distance. I mean, so it's like if it's at this distance and then it's at this distance and then you can compare them. That's better. That's good, right? Last time, Veritasium, I'm looking at you. You didn't really even talk about much about what it would do. You're just like, oh, it'd be bad. You're just like, oh, it'd be bad. If it's close, it's bad. But yeah, that was just mainly just to get people intrigued about learning about supernovas. And now we can actually get more insight into sort of what we'd expect. Of course, we don't really know the exact stuff, right? We can only make estimates and guesses based on what we know about the radiation and the way explosions work and all that. We'd be pretty fucked if it's really close. Even if Alpha Centauri blew up, some of those stars, people could still live in bunkers, and the motherfuckers at the depths of the Mariana Trench, not the Mariana Trench, but you know what I mean, like the depths of the ocean, but that's like the Hadal Zone, where there's like no sunlight. Those people, not people, but like those animals would be relatively unscathed. I don't know, maybe. Perhaps they would be relatively unscathed, and that's kind of crazy to think about. Anyways, guys, I'll catch you guys on the next one. Let me know what you guys think. Let me know if you made it all the way to the end, and I'm going to just end it right there. I don't know if I have much else to say, man. I mean, hopefully nothing in Alpha Centauri ends up blowing up. That's all I can say. And the other ones, they seem relatively like whatever, to be honest. Like the further ones away, it's just like it's whatever. But the ozone layer getting destroyed, how does that look visually, like in real life? I would want to know what that looks like. Not that I would want to know, but I'd be curious enough. You know what I mean. I'm curious to know what it's like. I don't really want to know what it looks like, though.